right. Welcome, YouTube. We are live. We are here. This is our lecture today for college algebra. Today we're going to be looking at section 2.4, linear functions. How is everybody doing today? Good. How was your weekend? Wait. What? I am excited to be here today. I am doing so good. Thank you very. You see, it's ironic or it's opposite. Y'all had a good weekend? Yeah. Anything exciting? Any Pisceans in the house?
You say what?
Pisces. I think we're in Pisces. You Pisces? Hey. You know my sign by now. You still don't know my sign after that whole thing? Yes, I'm a Pisces. Okay.
Is your birthday around the corner?
Yes. It happens. I've celebrated my birthday in spring break since I've been in undergrad. That was like 2000. Since 2002, my birthday has always fallen on spring break because when I was a student, it did it for school, and then when I got into grad school, it's always been spring break has always been on my birthday, so I've been having a blast. So that's always been fun. I turned 21 in Africa for spring break, all sorts of stuff like that. I always get the time off. I was like, oh, well, let's go do something. So I always get on some little adventure. Um, but anyway, that's neither here nor there. So I'm excited. I got one coming up. So that should give you. You should know how old I am by now. So I know you still don't know. I said by spring break, I said to turn 21. If I turn 21 in 2005, I'll let you figure that out. Okay, so you can do the math. Okay, so that's a little bit about me. All right. So today we're doing 2 4 linear functions. Okay, we need to have a quick discussion. Oh, look at this! My math student's doing some math. Oh, that's what's up. Okay, yes, that's correct. That is correct. I forget. I never really know how old I am. I always do the calculation. Like I never really know. I know the year I was born. I think I was like 28 for about 3 or 4 years, something like that. So, because I forget. But anyway, yeah. So today is what, Monday. So this Friday we are having our exam 3 over the first half of chapter 2, right? Right. I think the study guide is already loaded on my math lab. So I think all of chapter 2 is loaded. Study guide is loaded. Today we're definitely going to get through 2 4. Come hell or high water, we'll get through 2 4. Wednesday, I got to keep going forward with new material because I would like to get to the end of chapter 2 for the final for next week. All right. So the information is there. It's a good idea to go online onto my math lab and do those assignments early. I went live a couple of times over the weekend. If you were in attendance in any of those sessions, I think there were some extra credit opportunities, so you got to follow those instructions. It's still a good idea to go ahead and subscribe to my YouTube channel and turn on your notifications. If I ever do go live, there might be extra credit opportunities in there if you for participating. So just kind of be on the lookout for those. I've been kind of making them huge extra credit opportunities, so you want to just look into that. So exam is this Friday over the first half of chapter 2. All of chapter 2 is already loaded in my math lab. We have a final next week, chapter 1 and chapter 2. Okay? All the information is loaded. To prepare for the final, you want to study your old study guide, old exams. Honestly, if you know my study guide, you should be okay for my exam. I'm not really trying to trick anybody. I see I'm coming. I'm not trying to trick anybody or anything like that. Because we're on the quarter system, I don't mind the setup that I have. Okay, so what that means is as soon as you can, as early as you can, do the work that I suggest. Go ahead and have it ready to go. You should be okay for the exam. Okay, I'm not trying to be tricky or anything like that. Go ahead. The recent one is just over the first half of chapter 2. Yeah, yeah. So we're gonna finish out the last of the new material now, and we'll be ready for the exam on Friday. I do respond to questions. So when you click on the Ask My Instructor link, I make dedicated YouTube videos. I did at least 2 over the weekend with extra credit opportunities. So again, you want to tune into those. Okay. Any other questions, comments, or concerns before we get the party started? We're not gonna have that. Okay. I was just thinking of a math joke. I think I shared this one. I don't know if I shared this with you all or not, but what did the I think it was like I think it goes, what did the frog say when it sat on the what did the frog say when it sat on the tree while studying mathematics? logs are becoming natural. Something like that. The whole point was, you get it. Anyway, we're not even there. That's like 1 or 2 chapters ahead. But I know we're not gonna get to it. That's a whole really bad. Okay, it's bad. Okay, but just to change up the energy. Okay, so now we're moving into section 2 for linear functions, graph and linear functions, standard form. Okay, let's get it going. Okay, so I'm gonna assume that that's working because I have not changed any settings, so it should be okay. We're gonna move forward. So a function f, that's supposed to be an f. It's just a typo. It just didn't print properly. A function f is a linear function if f of x equals a times x plus b, ax plus b. For real numbers a and b, if a is not 0, and the domain and range of a linear function are both, they're supposed to be negative infinity to infinity. So let me make these adjustments. Give me a color. I think I heard blue. So a function f, and this is supposed to be negative infinity to infinity. Okay? Let's keep it going. So graph f of x equal to negative 2x plus 6, give the domain and range. Now, to graph a straight line, what do we need? 2 points, right? So we just need 2 points to graph a straight line. If we have f of x equals a negative 2x plus 6, what's the easiest way to graph this?
Find the y-intercept.
Okay, what is the y-intercept? Or how do we find the y-intercept?
Look at the constant.
The constant, right? The constant is the y-intercept. She's on it. That's okay. This is good. So y-intercept. What's the y-intercept here? 6, right? What does the negative 2 tell us in this form? The slope. The slope tells us how to get to a second point. What is slope? What over what? Rise over run. What? So what's its slope? Negative 2 over 1. So when we trace this graph from left to right, should it go up or should it go down? Down, because the slope is negative. When we trace it left to right, it's going to go down. That's what a negative slope means, right? So now, it seems like what we have going on, if we did a quick sketch, we said positive 6 with a negative slope, something like that's going on, right? So now, if this graph is correct, so the domain is the very left to the very right. What's the domain of this graph or this function? How far left does this graph go? How far right does the graph go? Okay, so the domain goes from negative infinity to infinity. The range goes from the very bottom to the very top. How far down does the graph go? And how far up does it go? Okay, so we have to use our imagination a lot here. Any questions on this so far? So the text decided to find the x and y intercept. To find the x-intercept, what did we do? Set y equal to 0. So the x-intercept set y equal to 0. That's what they did, right? We set the y to 0 and solve. To find the y-intercept, we set x to 0 and solve. All right? So that's what we did. And notice that graph is similar to what we got. Any questions here? Is this okay? All right, I'm going to move forward. Okay, this one says graph, we have f of x equals to negative 3. Can you tell me what does this graph look like? Okay, here. What is it saying? What is the y value here? Okay, scratch that. So let's let x be 1, right? If x is 1, what's y? Okay, if x were 5, what's y?
No, well, it would be negative 3 over 5, ain't it?
There's no x on the right to plug in.
Well, why you have to
So, okay. So what this is saying, we have f of x equal to negative 3. Come on. What this means is that y is always equal to negative 3. There's no x on the right. So no matter what x value we choose, y is always negative 3. So when x is 0, what's the y value? When x is negative 7, what's the y value? When x is 1,000,000, what's the y value? So now, no matter what x we choose, we get the same y value. What is that graph going to look like?
Is it like this?
Yes, it's a flat horizontal line. That was the whole point. Yes. Yeah, yes. Okay? Yes. So, again, so what this is saying is no matter what x we choose, y is always negative 3. So this is going to be a horizontal line through what? Y equals what? Negative 3. Okay? Does that make sense? Go ahead. It probably got answered. Did it get answered? Go ahead. You can ask it.
But I'm saying, like, we see stuff like this all the time. So the reason it's like that is because it's no.
Because it's no x. Yeah, because like no matter what x we choose, there was no x on the right hand side for us to replace.
Right. Okay.
So it just says that. Yeah. So it just has a slope slope of 0. Yeah, slope of 0. Yeah.
I understand.
Okay. All right. So let's keep moving. I meant to ask domain and range, but that's okay. Okay. We kind of actually need to talk about this. Let's see. I'll use this. I'll use this graph for right now. 1, 2, 3. So can we go like this? And oh, okay. Now, if this, hopefully this isn't too confusing because of the multiple lines. If the purple is our line, tell me about the domain, the very left to the very right. How far left does the graph go? How far right does the graph go? Okay, so that domain sounds good. Now we look at the range. How far down does the graph go? -3, right. It goes down to -3, right? How far up does it go?
It's not infinity, it's 0, isn't it?
How far up does it go?
It don't go.
It stays at -3. It doesn't go up, right? So you all are saying the same thing different ways. So now, so this is another way that we can look at domain and range. Domain is the very left to the very right. If we had a light source, below the graph and it was shining, so that the shadow falls onto the x-axis, that's the domain actually. The domain is the projection of our graph onto the x-axis. So if we were to take our graph and smush it onto the x-axis, that's the domain. Okay? If we took this graph and smushed it onto the y-axis, it would collapse to a what in this case? If we smush it onto the y. So notice, yeah, because it's a flat horizontal line, if we smush it onto the y-axis, it collapses to a point. So that's the projection of this graph onto the y-axis. That's like the shadow. Whenever you hear me use the word projection, I'm just talking about like a shadow cast onto the, like if there was a light source to shine the light on the right-hand side onto the y-axis, the shadow cast would be a dot. That's what we mean by projection. So if we were to take this and smush it onto the y-axis, that's what we mean by range. If we were to take our graph and to smush it onto the x-axis, that's what we mean by domain. If we were to shine the light from the bottom and it casts a shadow onto the x-axis, it would cover the whole x-axis. That's what we say, negative infinity to infinity. That's what we really mean by domain and range. The left and right, that's one level. You know, I'm just kind of giving you a little bit. So the domain is the shadow cast onto, or the projection of our graph onto the x-axis. It's like you smush it onto the x-axis. The range is the projection of our graph onto the y-axis. So that's really what's going on. If that's too much, domain is the very left of the graph to the very right. The range is the very bottom to the very top. Okay, so either one of those is fine. Okay, I'm going to move forward. That smells so delicious. Okay, so I think we got the negative infinity to infinity is fine. Now, if it's just 1 point, we're going to use curly brackets. Because the curly brackets means just, you know, a discrete set, like just this number. If we did, yeah, that's all that we would do here in this case. So you see the domain is negative infinity to infinity, and then the range is just -3. Okay, questions, comments, and concerns? So in this context, if we were to use like parentheses, for instance, if we had parentheses, I don't know, -5 to 7, then that means we're talking about all the numbers between -5 to 7. We didn't do an attendance, not yet. If we have parentheses, then we're talking about all the numbers in between, not including the endpoints, right? But if we use square brackets means we're talking about all the numbers in between and we include the endpoints. A square bracket means we include the endpoints. Curly bracket is used for a discrete set, meaning like if we had curly bracket 3, comma 4, comma 5, close curly bracket, then that means we're talking about just the number 3, just the number 4, just the number 5. It's a discrete set. So none of them numbers in between. So there was something else I wanted to mention, but that's enough. Okay, any other questions, comments, and concerns before I go forward? Can you start an attendance for me? Put today's date. Yeah, thank you. All right, let's move forward. All right, so now this one has a similar explanation as the previous. This one says graph x equal to -3. So what is this graph saying? X is always equal to what? So then now, instead of choosing values of x, let's choose values of y. So say y is 0, what's going to be the value of x? Say y was 2, what's going to be the value of x? Say, see, no matter what y I choose, it has the same same x value, right? If we were to plot all those points, what will the graph look like? It's a straight up and down vertical line. Does that make sense? It's a vertical line. Can't think of anything else. Okay, so now if we have a vertical line, tell me about the domain. How far left does the graph go in this case? How far right does the graph go? Is that okay? So the domain is just the number -3. Let's look at the range. How far down does it go? And how far up does it go? So the range is all reals. Any questions here? Okay, so we have our domain and range. Okay. So again, this original is saying that x is always -3. So no matter what y value we choose, we plot that x value. Okay, let's keep going. Questions, comments, and concerns before I go forward? Oh, I am having a hard time. I'm so sleepy. I had the strangest experience in the middle of the night. What does fast asleep mean? What does that mean?
I think you go to sleep without.
Oh, okay. So I was slow asleep? I don't know. I don't know. Yeah, I guess that's what was happening because I was asleep. Next thing I know, I had the most intense pain in my mouth. I was like, whoa. I guess because like in your sleep, you like clench your teeth. I bit my tongue and it was like bleeding. I was like, oh. I don't know. I was asleep. I was asleep and I just woke up. That's never happened before.
I clenched my teeth before I woke up. My jaws hurt, but my tongue.
Yeah, so I was like, oh. But I mean, it's just more of an inconvenience than anything. And luckily, it's not bad or anything. But but once I woke up, I was like, I responded. I did respond to one. Somebody emailed and I made a video response for.
I saw that.
Okay.
Like,
but I'm usually up. That's why I'll be like so sleepy when I get in here, and that's why I try to bring some energy because it's like I'm going through contrast. It's like I so want to go to sleep, but I can bring the energy, so it's like I'm a zombie. It's so strange. But I'm usually up like Mobile Legends and like on the sticks and stuff. I figured out this character, this new character. I was having such a hard time, and I was watching the video, and it finally clicked, and I tried it out. Oh, she is OP. So now she's like a beast, and it's just so much fun. So I just be like this. Yeah, it's a character on Mobile Legends called Guinevere. Mobile Legends. Yeah, it's just a 5-on-5 battle royale. It's a lot of fun, but it's really frustrating because it's all about cooperation. And so each match, if you don't have a squad or a team, you get new people. So it can be really frustrating working with trolls. Like you expecting them to protect you, and they just run away. He's like, no, just shoot them, save me, But it's a lot of fun. But I say that to say, a lot of times I'm up in the middle of the night, and so I'm really really tired right now. But anyway, so I'm just trying to stay awake. Okay. So I think we did this one. I'm going to move forward. Any other questions, comments, and concerns before we go forward? Okay. Yeah, so we saw this graph. We talked about domain and range, so that was good. Let's keep going. All right, motion problems. Okay. So in this text, we'll agree that the coefficients and constants in a linear equation are rational numbers. Then we'll consider the standard form to be ax plus by equal to c, where a is non-negative. What's the difference between positive and non-negative?
Positive and positive. There's no positive. Whoa. I'm sorry. It's not -0? No, it could be a fraction.
Yes. Your first thing that you said was correct.
Oh,
Non-negative means not only is it it's not negative. So that means it could be 0 or positive. Positive means it's only positive. It doesn't include 0.
Like 50 different things in my head.
So if you ever hear mathematicians saying non-negative, they mean positive, but they say also include 0. Yeah.
So if you just say positive and not include 0?
Yeah, when you say strictly positive, you don't include 0. Yeah. higher than 0. Not necessarily 1, because it could be a fraction, some kind of. Yeah, that's all that this is. This is imagination. The best kind of nation, imagination. The best kind of ships, friendships. Okay. The best kind of prizes, surprises. Oh, okay. All right. All right, that's enough of that. Oh, okay. All right, so where A is positive, A, B, and C are integers, and the greatest common factor of A, B, and C is 1. If 2 or more integers have a greatest common factor of 1, they are said to be relatively prime. Okay, let's keep going. That's all back stuff. We're asked to graph this. Okay, what's the highest exponent on any term here? 1. So what kind of graph should we anticipate? A straight. Yeah, a straight line. The highest exponent is a 1, so it's a straight line. Hence the title of this section, linear functions. What's the easiest way to graph a line? Find the what? X and Y intercepts, right? Okay. So when we go to find the intercepts, my suggestion, find the Y intercept first. More often than not, that's easier to find than the X intercept. To find the Y intercept, what do we do? Set. If we set X is 0 in this case, what Y intercept do we get? We get negative 5y equals 0. So you should probably write it. I was trying not to write it, but we probably should write it. Okay. So if we let x be 0, I think we all see this. Now that we write it and we get out of our head, now can you tell me the answer? Y equals 0. Yes. You see that? You divide both sides by negative 5. So the other thing with this, try not to do so much in your head. Write stuff down. Write it all the way out. Because then that'll help you to see it. You can get out of your head and you can focus on what. But when you're trying to do it in your head, you're not only trying to remember the equation, but then you're also trying to process. Simplify the process. Get past the lazy factor. Write it all the way out. Write it out and you'll see it. It'll be super clear. So now, in this case, we let x be 0. Y happens to be 0. If we let y be 0, x is going to be 0. So the only x and y intercept is the origin. So we actually need another way to find the second point. Does that make sense? The origin is the only intercept that we have. So how can we find the second point? Okay, yeah, we can plug in the value for y, find the corresponding x. We can solve for y. There's a number of ways we can do this, okay? So I'm going to go ahead and show the result, okay? We got the x and y intercepts as the origin. So if we wanted a graph, we just need a second point. You can choose a value for x, find the corresponding y. We could solve for y, okay? So on and so on. Is this okay? All we did for this one, we just chose some value of x. We said let x be 5. Find the corresponding y. So when x is 5, then y just happened to be 4. So then a second order pair is 5, 4. So then we plot the 2 points, connect them with a straight line. In this one, we can, yeah. In this example, we can, yeah.
So when is 0?
In this example. Because we know it was a straight line because the highest exponent was a 1. So in order to graph a straight line, we needed 2 points. Usually we can do the x and y intercept, but they happen to be the same, so we didn't get 2 different points. So we had to find some other point, so then we chose any x. For instance, if you let x be 2, if x is 2, that's what? 8 times 2 is 16. That's going to be a negative 16. You're going to get a fraction. But negative 16 divided by 5, so negative 16 over 5. That's like 3 1/5. Negative 3 1/5. 3 1/5, sorry. But anyway, you choose the x, find the corresponding y, you plot it, connect it with a straight line. Does that make sense?
But you only do it when it's over 0.
Wait, because we're trying to graph a straight line. To graph a straight line, you need 2 points.
So when it's a straight line, that's when you can set it to 0.
Well, when it's a straight line, we need 2 points. The easiest 2 points to find are the x and y intercepts. But we didn't get 2 points when we did the x and y intercept. So we had to get a little creative and find a second point. Yeah. You know what responsibility means, right? Ability to have a creative response. I'm just saying it because I use the word creative. Anyway, I'm just saying that because I said creative. It made me think of the statement. Responsibility is your ability to have a creative response. That's what responsibility. Anyway, let's keep it moving. So I'm gonna let this be. Any other questions before I go forward? Pardon? Thank you. 12:18. All right, let's keep it going. Yeah. Okay. Slope. I think okay, so slope is rise over run. It's a change in y over change in x. I'm going to let that be. It's y2 minus y1 over x2 minus x1. I'm going to let that be for now. So here's slope right here. So slope is the rise over the run. It's the change in y over the change in x, which is the y2 minus y1 over x2 minus x1. This is a formula you should know. This is one that you should probably add to your formula sheet. Okay? All right, I'm going to keep going. The triangle is delta. It's a Greek letter called delta. It just means, in this context, it means change. So again, slope is the rise over run, which is the change in y over the change in x, which is given by this formula. Please don't die on me. I'm coming. I'm coming. Don't die on me. It's gonna throw off my rhythm. All right. Had to give myself some power. All right. Let's keep it going. All right. Any other questions, comments, or concerns before I go forward? Okay. So when using this formula, be sure to be consistent with the order. Again, the formula goes y2 minus y1 over x2 minus x1. It's actually okay to do y1 minus y2 over x1 minus x2. But what's the trouble with the second two?
That's confusing. What? Oh, because x2 is faster.
Yeah, the order wasn't consistent. In the first two, they were consistent. They did the twos first or the ones first. But in the second two, they weren't being consistent, so it's going to throw off the answer. For instance, if you look at the third one, it says y2 minus y1, but then they switched it on the bottom and said x1 minus x2. That's going to throw it off. We got to be consistent. So the two on the left are fine, but the two on the right are no good.
So how come you can do y1 minus y2 x1 minus x2? I thought it was only the first one.
You just got to be consistent. It's like an additive property of equality, commutative property. You just got to be consistent. That's about the best explanation I can give right now for that. Yeah. Yeah, and that's fine. That's A-okay.
I'll be trying to remember just one formula.
That's fine. That's perfect. All right. The slope of a vertical line is undefined. So remember, the horizontal line had a slope of 0. A vertical line the slope is gonna be undefined. So that slope is gonna be undefined. All right. We're asked to find the slope of the line. Oh, again, the suggestion is every time we use a formula, write it down. So the slope is the rise over the run. It's going to be y2 minus y1 over x2 minus x1. And then usually when I get points like this, I just automatically do the following. x1, y1, x2, y2. Yeah, there's a bit of a lag. I don't know what to do with that. Probably got to delete some stuff. Whatever, but yeah. So now, let's keep going. So if we plug this in, what's our y2? -3. Minus, what's y1? 8. What's x2? 2 minus, what's x1? -4. Notice my use of parentheses. Notice the use of parentheses. So what does the top become? -11. What happens in the bottom? Okay, keep change sounds good. Yes. 6, right? So double negative becomes positive in this case. So then it becomes 2 plus 4 should be 6. So that should be the slope between these 2 points. And you see it right there. Ooh. Ooh, okay, let's keep it going. Yeah, it's very strange. Like I'm so sleepy. Like I can be fast asleep right now, but I can kind of keep the energy going to stay awake. Go ahead.
So for the, does it matter if you keep the negative sign on the denominator, or do you have to keep it like what we counting from?
What do you mean?
Like where it says -11/6 and then negative.
Oh, okay, okay. So, give me give me a color. Give me a color. Purple. Okay, so the question is, does it matter where the negative appears in our answer? So I'll say this. -11/6 is the same as -11/6 is the same as 11 over -6. These all are the same.
So you're gonna go the opposite way too.
They're all the same. You can use any one that you want. We typically will either do one of the first two, but they all mean the same thing. Okay. Okay, let's keep going. Find the slope. All right. Find the slope of the line through the given points. Let's do another one. Okay, wait. What do we notice going on here? We have repeating what? So we go over 2 and up 7 and then over 2 and down 4. If we were to plot those, what would happen? The vertical line says right down the same vertical line. So what kind of slope should we anticipate? We said a vertical line that has undefined slope. Okay? So we would anticipate an undefined slope. Let's see what happens. So the slope, y2 minus y1 over x2 minus x1. We said x1, y1, x2, y2. Okay? Okay. What's y2? Tell me about y2. Y2 is -4. Tell me about y1. 7, right? Tell me about x2. So 2 minus what? 7? No. 2 minus 2, right? So on top, what do we get on top? -11. What do we get on bottom? 0. You see it now? Undefined. Remember that?
Oh yeah, because it said the slope of a vertical line.
Well, why is that undefined? What happens? Yeah, we can't divide. We can't divide by 0, right? Is that okay? Oh, sorry. Okay, let's keep going. So yeah, it should be undefined, and we're good to go. All right. Okay, now notice in the last one what happened. So what do you notice about this one? What's repeated? So we went what? Right 5 and then down 3, and then we go left 2 and down 3. So then when we plot those points, what would happen? Horizontal line, right? What's the slope of a horizontal line? 0. You do this a similar kind of thing, you're gonna get a similar result. Okay, so this all kind of repeats. 0 slope. How many slides? Okay. Thank you. Okay, yeah. So we just did that one. Oh. Okay. Okay. If we wanted to find a slope here, what would you do? Pardon? You said find the intercept? Okay, if we found the intercepts, that would give us what? 2 what? If we found the intercepts, that would give us 2 points. Now that we have 2 points, can we plug it into the slope formula? Yeah, that's one technique that you can definitely do. Can someone tell me the slope? Okay, so you can find 2 points What's another way that we can find the slope here? Solve for y, right? If we solve for y, then you're going to get the form y equals mx plus b. That's another way. Both of those ways, you should get the same result. Okay? I'm going to just go ahead and go. So they chose to solve for y, but what you all said was actually valuable. It would actually work. Okay? But you should get the same result. It's probably a good idea to make sure, just go ahead and try both and make sure that they work. If you're not able to get it to work, just let me know. This one, yeah, the intercepts. So this one they solve for y. We originally suggested to solve for the intercepts. Yeah, it says find the slope of the line, so we know it's a straight line. So we can find 2 points on the line, and then find the slope between those 2 points.
How do you say we knew if it was a straight line again?
The highest exponent is a 1. Okay? All right. Yeah. Okay, so it says graph the line passing through this and having this slope. Did we talk about the 3 equations for a line? Okay.
I think we showed this.
I think it was a long time ago. Like, yeah. So we have a slope and a point. We're going to use the point slope. Anybody remember point slope formula?
Isn't that that long version that I don't know if you showed it. I remember you showing it.
Y minus y1 equals m times x. Is this right?
Yes.
Minus.
That.
Yeah. Because remember, this was the same as a slope formula, but we just multiplied both sides by the denominator, and we just dropped the 2's. Forget about that. Well, if you use a slope formula, you would need 2 points. You see what I'm saying? I mean, you can use the slope and that point to find the second point, but it's essentially the same thing. Okay? So this is going to be our x1, y1, and we have our slope. So then we can just plug those into the formula, and we should be good to go. Okay, so let's do that. Let's do it. So y1 is 5. I'll do green. We're going to say y minus 5. The slope is what? Negative 5 by 3. X minus a negative 1. Is that right? What are we trying to find? Line passing through, so it's going to be y equals mx plus b. So long story short, we need to solve for y. If we add 5 to both sides, plus 5, then we get that y equals 5 by 3x. That's 15 minus 5 is 10 by 3. So then if we ask to find the slope should be 5. Wait a minute. Oh, negative 5 by 3. I just didn't bring down the negative. Wait. Yes.
Oh, I see what it does now.
Well, I don't think that this would be the best way to graph this, because then we gotta do a y-intercept of 10 by 3. What point is that if we say 10 by 3? How many 3's are in 10? 3. And then there's a remainder of 1, so that's 3 1/3. So it's just slightly, the y-intercept is slightly above 3 1/3, right? Or right at 3 1/3. And then we have a slope of negative 5 by 3. So if the slope is negative 5 by 3, when we trace the graph from left to right, should it go up or should it go down? It should go down. All right, let's look at it. I am. I can go to sleep pretty quick right now. I can be fast asleep in an instant. Oh, I know. I'm really trying not to watch the clock and just trying to get through this section. I'm trying to focus. Oh yeah. I'm gonna definitely take a break. I gotta pause. Yeah, just gotta get up, and that's why I got this food here to try to give myself some energy. I had the window because I'm hot.
That makes me tired.
That's probably what's going on. I mean, it's
But I always have on a blanket. It's just, I don't know. It's weird. It just makes me go.
okay. So that's going to take some practice on your part. So make sure that you're comfortable graphing these. Okay. Slopes. I'm gonna. We've discussed all this. I'm gonna let that be. All right. So, was that it? Okay. So for this course, just for this course, if you ever see average rate of change, we're really just saying the slope. So it's really just saying find the slope between 2 points. All right. What's this? Okay. So in 1980, the average monthly rate for basic TV in the United States was $7.69 in 2008. The average monthly rate was $46.13. Assume a linear relationship and find the average rate of change in the monthly rate per year. Graph as a line segment and interpret the results. Pardon? Right. Yeah. Yeah. That's all they did. It says find the average rate of change. In other words, they just find the slope between 2 points. So they wrote the two ordered pairs and then used a slope formula to find the slope between the two. That's all that happened. Okay. So then they just found the slope. All right. Linear models. So a linear cost function has the form C of x equals mx plus b, where x represents the number of items produced, m is the variable cost per item, and b represents the fixed cost. Okay, I'm going to let that be. Yeah, I'm going to let that be. So we saw what? A cost function. Then we have a revenue function. For selling a product depends on the price per unit. So this depends on the price, P, and the number of items sold, X. Is given by this. Profit is found by subtracting cost from revenue and is described as a profit function. So we have the cost function, we have the revenue function, we have the profit function. Profit is revenue minus cost. Is that okay? Revenue is the money generated. Cost is the. Yeah, it just needed exposure because it can be a little dicey. It definitely can be a little bit. You have to. This is all about. These things are about your ability to organize. So clearly identify your labels, draw relevant pictures. You're gonna have to read it several times over. If you're asking for profit, then that means we need a revenue function and cost function. And then so then we got to go back and see the proper way to calculate revenue. Go back and see how to calculate cost. This is already. You have a copy of this stuff. Okay. All right. I'm going to keep going. All right. Assume that the cost to produce an item is a linear function and all items produced are sold. The fixed cost is this. The variable cost per item is this, and the item sells for this. Write linear functions. Write linear functions to model the cost function. So the cost. Let's look at it one more time. Right here. A linear cost function is given by this, where x is going to be the number of items produced. M is going to be the variable cost per item. And B is going to be the fixed cost. What's the variable cost per item? Oh, well, 100, yeah. And then what's the fixed cost? 1,500, right? Whew. So then, yeah, I don't know. I started strong and then it's just like that. I'm gonna have to get up soon, but yeah, I'm about to get up. I'm just trying to finish out this section because we're actually almost there. I think this is okay though. I'm not gonna go deeper into this. Let's keep going. Our B asking us to find the revenue function. Let's see. The item sells for $125. So it's gonna be what? the sale price times the number of units sold. So it should be the revenue should be the sale price times the number times each X. So then profit is going to be revenue minus cost. All right. So the profit function is just going to be R minus C, and we crunch that number. We get this. Then we want to see the solution. How many items must be sold for the company to make a profit? So once we have our profit function, if we want to make a profit, how much? If we want to make a profit, let me see. So okay, we can see the profit function at the top of the screen, right? If we want to turn a profit, what needs to happen? We need it to be what kind of numbers? Tell me about them. Or yeah, we want it to be positive, right? Does that make sense? So we need the profit to be greater than what? 0, right? So we were doing inequality. We would have like the 2x, 25x minus the 1500 needs to be strictly greater than 0. And then solve the inequality. Or you can just set the original to 0 and solve. So you see it here. Okay. So in order to turn a profit, we need to sell more than 61. When we sell 61, we should break even. Once we sell more than 61, we should turn a profit. Okay, so that ends this section. We're going to stop here for the moment, and we're going to reconvene on another. And so from one beautiful mind to another, enjoy the rest of your day. Not you all. We got another section we're about to do. I just talking to the people on YouTube.